Hi everybody, my name is Butch Doss. I work for the R.E. Michael Company. I'm a TSA, Technical Service Advisor for the company, and also a trainer. I've been in this business a long time. I'm 66 years old. I took it in high school when I was 14. And I got a degree in 1971. I owned a business for many, many years and sold my company and went to work for R.E. Michael 15 years ago in the capacity of a TSA. Love training, like helping you guys. A lot of you guys that know me down south. I'm for you, not against you. Amen. And so what we're going to do today is talk about the Fujitsu product we brought on. It's a very good product in my opinion. It's a tube and fin coil product. We're going to talk about fundamentals today, basic heat pumps, so you can understand when you buy this product, it maybe help you install it and understand the little nuances, because a man doesn't trip over a mountain. He trips over a pebble. So we're going to try to get help you to watch for pebbles today. How about it? So let's get started. We're going to start by going through a video. This is about these fundamentals. We're going to talk about the fundamentals of the heat pump. We're going to talk about the wiring of it, the airflow, the piping on it, refrigerant charge, which is very important, long line refrigerant settings and stuff, pipe details, and defrost. And we're going to do little segments of it, and we'll stop, take a break, and do more. Right? So heat pump, fundamentals of heat pump. First off, this is a straight AC system. You see it has a compressor, an evaporator, and a condenser coil with a metering device, whether it's a piston or a TXV. Fujitsu uses TXVs, and it's got a single flow dryer flowing one way. And pretty simple, been around forever and ever, first ones that were invented. And all they have one purpose, and that is to remove heat out of a structure and put it somewhere where it's unobjectionable. We don't object to it, right? Well, there's a lot of difference in that. So now we go into a heat pump, and what is the difference? Well, first off, if you ever take a NATE test or some state test, it has an indoor and an outdoor coil, and they're called heat exchangers now. They're no longer evaporator and condensers on a straight AC and stuff. So they have an indoor-outdoor coil, and it can be the evaporator or the condenser depending on the mode it's in, right? It also has two expansion valves now, not just one, two, to operate it in the heat mode or the cool mode. It has a bi-flow dryer, which points different directions. A lot of times, I get a lot of calls sometimes. I'll ask the guy to look at the dryer on a heat pump, and he'll say it's got an arrow one direction, and I'll tell him, go get one with two, and then the problem's solved. So be careful about that. Watch, make sure you look at the dryer before you install it. That's the key to that. That's one of them pebbles, right? It also has a reversing valve or a four-way valve. If you take some tests, it'll be called a four-way valve, but it's a reversing valve down south here. And what does it do? It directs refrigerant, right? So two expansion valves, not just one, a bi-flow dryer, a reversing valve, and an indoor and outdoor coil for a heat pump, right? And so, there's these with Fujitsu, they reverse in the cool mode. Reversing valve is energized in the heating mode, right? It's de-energized in the cool mode, like Riemann Rudd and like Bosch. So you got to be careful about that little pebble, because I get a lot of calls and they wire it up and they say, Butch is kicking on the high pressure is kicking when I turn it into the cool mode, and I go in there and ask them if it's on O or B, and they'll tell me O, and I say, well, go program the stat, and the problem's solved, right? So you got to make sure that that is on in the cooling mode. So if you put it on the cooling mode, the valve will de-energize, right? It's de-energized, and what happens is the discharge will go out to the condensing unit, right, to the outdoor coil. And then take the discharge out there, high pressure vapor, which will become a high pressure liquid, go through the metering device, and of course a metering device, what does it do? It causes a pressure drop. It divides the high side from the low side, right? And then it'll return back to the compressor, right? So only one valve is being used at that time. In fact, the indoor valve the outdoor valve is being completely bypassed, right? And say then we go into the heating mode. Well, then we click it, and now since we've done that, our valve is energized. In other words, we got a 24-volt signal to the board, which is energizing the valve in order to drive the reversing valve to the other way. So now the discharge is going to go to the indoor coil, not the outdoor coil, right? It goes to the indoor coil and starts heating the room up, right? And of course, it goes to the high pressure vapor. It can be 120, 130, 140 degrees off that discharge, going into the coil, and then coming back, and of course, condensing it into a high pressure liquid, coming back to the outdoor metering device, which is operating now. The indoor metering device is completely bypassed and is not working at all, right? And so you understand how these two valves work. So in the heating mode, only one valve works, the outdoor one. In the cooling mode, only one valve works, the indoor. The other one, and they're completely bypassed. Right? Okay. And so here you got a valve. So there's a measure, and things happen to valves all the time. I get a call and they'll tell me that the valve is sticking one way or the other, right? And you can measure between two line sets right here. And you see right here, these two here, where the cooler lines are. In other words, the middle one is always true suction. This is always the discharge. And the other two are going to the outdoor and the indoor coil. So you always measure off the center one, right? And then the coldest one to the evaporator, whether it's outdoor or indoor, whether it's stuck in one mode or the other. So you take a measurement and you don't know more than 7 degrees. Some manufacturers say 5, I think 7. But usually if you have this happen, and I've seen it happen, there's usually 20, 30 degrees difference. What happens is some of this discharge gets mixed, right? And makes this one warmer than the other coil. And so, because the discharge is going straight to the compressor. Now, a lot of times you can take these things, and I ask people how do they shift? Well, they shift off pressure. This is a refrigerant line, right? And it pushes the valve this way. This line pushes this way, depending on how the solenoid opens up. So it shifts on pressure. So if you're 70 degrees in the fall, and you're wanting to bring it into heat, and it won't shift, and you'll call me, and I'll say, listen, what mode's it in? And you'll say, well, maybe it's in cooling. I'm trying to get the heating. And I'll say, well, unplug the condenser fan motor. And they'll say, well, Butch, why? I said, well, listen, if it moves off pressure, if it's 70 degrees outside and my head pressure is 290 and I can get it to 600, I'm more likely to move that valve, right? More likely to shift that valve if I put more pressure on it. So if I get it up to 600, that's fine. The high pressure control on this thing kicks out at 620, and it's got an internal bypass on the compressor, on scroll compressors, just in case it gets too much pressure to protect the compressor. You're not going to hurt the protection devices, and it may shift the valve. And after you do that, buy some Subco 88 or some AC Renew, put it in there, shift it a few times, and you'll never have to change it. I don't like changing reversing valves, and I don't think you do either. So that's the way. Now, if it's stuck in the heating mode, then unplug the evaporator fan motor, the indoor blower motor, or the air handler, or the gas furnace blower, so that the head pressure will build up, and shift that valve. And then I'm going to tell you, 60-70% of the time, that works because you apply more pressure to it. Right? So it shifts off what? Off pressure. The solenoid comes in and it shifts off pressure. The more likely it is to shift. And if it is stuck between there, you can still do the same thing. Unplug it, get the head pressure up. Maybe you'll push it the rest of the way. Right? If not, you're going to have to change the valve. Right? And here it is. I think Fujitsu did one good, wonderful thing, in my opinion, being an old service guy, is they made a big giant panel so you can get to everything. Look at this right here. You can get to everything in here. The expansion valve is right here. You have a muffler on this thing. It's gray. As you see it, I kind of like that they're trying to change some colors. Not everybody, but they have a muffler. I get a lot of guys call me and they said, they just replaced the dryer. And I ask them where they replaced it. They say on the discharge line of the compressor. Well, after you do that, there's a lot of junk in the system because that discharge blows that dryer to pieces. That is a muffler, not a dryer. And so be careful, don't never do that and stuff. But they did a great job so you could get in there, repair, do tests, do things just by taking a panel off. They even made the wires on the fan motor so long that you could actually take the blade off, lay it on the ground, and service inside. I remember when 13 SEER came out, they had so many things so tight in there, you couldn't do anything. I mean, it was just so hard to work on anything, and they were so tall that you just about had to get a crane to lower you down in there to fix anything. But they've done a good job. They're a very fine piece of equipment as far as the size of it is and stuff. Right? And so it has also something called a charge compensator, and that's exactly what it does. It compensates the charge on this thing because, and depending on the mode, all heat pumps use a imbalance of refrigerant. And I get a lot of guys who try to charge in the heating mode. I'll tell you, it's very, very hard. And usually, you just got to weigh it in, and that's the end of that. Subco superheat. When you're doing in the cooling mode is the way to go. So we need to have something to store the imbalance of refrigerant in this thing and stuff because of the larger sizes that are required to match the imbalance, right? So what happens is, why is it needed? Well, when the charge is coming and it's using the heat pump, the system imbalance between the heating and cooling modes. So we have a little more refrigerant we're going to have to use in one mode or the other, right? In fact, The mode is, we use a little more in the heating mode than the cooling mode with Fujitsu, right? It migrates when you're in the cooling mode. It migrates all the refrigerants. I'm in the cooling mode, so all of this will be cold. Remember, your 4 basic laws of refrigeration that liquid refrigerant always migrates to the coldest spot. Well, if this is the coldest spot, this charge compensator, then all your liquid refrigerant is going to migrate here. That's why we put belly bands on compressors, heaters, in order that liquid won't be in there when it starts up and wash all the oil out of it. So it migrates there, right, and stuff, and then here it is. So in the cooling, what do? We store. It's in the storage mode. So we're storing refrigerant in the cooling mode, right? And we're still doing sub-cool superheat, right? Doing sub-cool causes a TXV to charge. We test with superheat, right? So we're storing it here. And then when we go into the heating mode, we need more refrigerant in the heating mode. There's more capacity in the heating mode. I mean, it's the funniest thing. You look at the air conditioning or heat pump system, and you'll see at a lot of tech specs, they have more capacity in the heating mode than they do the cooling. So there it is. So it drives the refrigerant because the discharge is going straight through this line right here, driving all the excess refrigerant out into the system. Right? So there it is, cooling mode or defrost is going to store. Heating mode is going to drive it out in order to have enough refrigerant for this product to operate properly, right? So during the storage motions, you see it's just in cooling, and it all stores it up, and then in the heating mode, it drives it out and puts it back into the system, right? And so what do we have here? We have 2 TXVs, as we talked about before, with a heat pump with a straight AC. We have one piston, depending on the product you buy. And we have a bi-flow dryer. And both these TXVs have bypasses in them. Back in the old days, when heat pumps first come out, and I was in this business when they first came out, you had to build a mechanical check valve across the TXV to bypass it. But now it just looks like all TXVs have bypasses in them. I don't know of any that doesn't already have it in there. And so what happens is, if you're in the cooling mode, the outdoor one, right, is of no consequence. It's bypassing, and the indoor was working. So if I have an issue, like if say my TXV goes bad, I go in and I check my subcooling, and it's up to 25 degrees, right? In other words, my liquid line and my pressure, and the difference between them is 25 degrees at my point of saturation. Then I check my superheat, which is legitimate, and it's up to 30 or 40 degrees when it should be 8 to 12. Well, I know that TXV is stopped up, or this dryer is stopped up in one mode. It can stop up in one direction. I've seen that many, many times in my career. And so be careful about that, and you can take a temperature difference across the dryer to see if anything's happened. Now, and that's what's going to happen. So if it's stopped up in the cooling mode, the head pressure is going to go up, right? The suction pressure is going to go down. The subcooling is going to go up, and the superheat is going to go up. They both up, you got a restriction. Now, in the heating mode with this thing, the indoor bypasses it is of no effect to the system whatsoever. It's bypassing completely. It goes to the dryer. Then the outdoor TXV is working, and what happens every time when it goes bad and when it stops up or it closes off is the head pressure goes to the roof, and the suction pressure goes to nothing. In fact, it do it faster on the outdoor than it does the indoor because it's using more refrigerant. So that's how it works. And now I know that you're saying, well, now how am I going to check subcooling and superheat? It is very, very hard on a heat pump to check the outdoor one and that, but you can. You can still check the liquid line coming back, and you can check to see it, even though it's coming off the evaporator. But knowing that's the case, that the head pressure goes up and the suction goes up. If they both are going up, then maybe it's wide open. It's called a bypass metering device. So make sure you understand that. Right? And there's the bypass and this and all the little things. You see this spring right here, and all metering devices, for you guys that take NATE tests and state tests, all metering devices control superheat. I know you think that a lot of guys think it's all subcooling with TXVs. No, all metering devices control superheat, whether it's a piston, TXV, low side float, whatever it is. In fact, this spring right here is called a superheat spring, And most of these valves are set anywhere from 8 to 12 degrees. Some of them are 8 to 16. Of course, if you go to a house and you got an attic and you go out to the outdoor unit and test the superheat on the TXV, it might be 20. The best place, and really the only place to test it, is at the evaporator, in my opinion, right? And there it is, and now there's the bypass. How it bypasses the TXV, doesn't go through it, right? So That's pretty much how it works. And you got to be very careful about where you put the bulb to. Fujitsu did a good thing we're going to talk about in a minute. But yeah, does it matter? Well, it does matter a little bit. It sure does. In fact, if you got a 7/8 line or lower, you see you want to be at 10 and 2, right? 10 and 2. In other words, I'm not getting liquid down here. It may be getting a false coda reading that I should be getting, right? If you got an 1 1/8 bigger, you want to get bigger than 7/8, 1 1/8, which is very rare. You know, maybe our 5-ton on a long line on Fujitsu. On some other models, you'll have an 1 1/8 above 25 foot. You want to put it at 4 and 8 o'clock. So make sure you strap them down properly, right? So they've done good. They've done good with this. I prefer this where they put the TXV and they don't mount the bulb. I go on many jobs, and it's a sad thing to see where somebody is brazing, right? Excuse me, brazing, and they bust that bulb because they got the copper too hot on that, and that happens. Be honest with you, a little more than it should. You know, when we have all kind of heat block, you can go to RE Michael, buy a tube of heat block. You can take a wet rag and put it around it. You know, even though I'm not a proponent of water around refrigeration, the heat block is better, and that way you're not busting your valves. But the truth of it is it happens. A guy maybe not used to brazing or has a little trouble brazing, and it gets it too hot and busts the bulb. Well, Fujitsu has taken their bulb and not mounted it at all until it's already brazed, which absolutely makes perfect sense to me. And it's on the outside. I don't have to worry about if it's positioned right or if it's doing this. I go to a lot of them, and they're in a vertical position. You know, when you read all the books, it says don't do that. But at the same time, manufacturers do what they need to do to make their product work, obviously. So it comes with 2 straps, and you can, after you brazed and cool it off, you can strap it down there in the proper position, right? So failure to secure it's going to mess up, it's going to mess the system. And you got to cover, you got to insulate it, and then make sure you insulate it good, because you don't want it reading attic air, you don't want it reading under the house air. You want it to operate properly. If you don't insulate it properly, it's going to fail to provide the SEER rating and also the capacity that it needs in order to supply the right refrigerant flow in the system, right? So make sure that. So, you know, make sure you braze properly, make sure you don't do that. And also listen, in brazing, use nitrogen. My goodness, I know I've been preaching to the choir this for years now. The truth of it is, without that, you end up with all kind of junk in these things, and next thing you know, it gets stopped up. In fact, between 2013, we had a thing called coagulation. Now, some of you guys know what I'm talking about, because Copeland introduced a rust inhibitor in a compressor, and it mixed with the POE oil, and then it stopped up in the expansion valves. But the truth of it is, a lot of guys didn't have that trouble because they used nitrogen. That coagulation, that POA had to mix with the scale, the oxidation on because it didn't use nitrogen, and it mixed with that, and it stuck to that TXV. So there's a lot of them out there that it never had any issues. Why? They use nitrogen. Yeah, in fact, even with a TXV, I mean a reversing valve, you take and you use nitrogen anytime you braze, and they're very small clearances there, right? The reason most of them stick is because they're not using nitrogen. A little minute particle of scale will get in there and stop that thing, stop it halfway. You might be able to push it and get that AC Renew or Subco 88, go down to RE Michael, buy you some, and put it in there and never have any issues anymore. But the truth of it is, if you use nitrogen, you're going to cut down, refrigeration-wise, probably 15 to 20% of your calls. So get you a tank of nitrogen, use it when you braze, and I promise you, you'll be happy that you did. Right? And so now we have high and low pressure switches on these things. Fujitsu decided, and I'm glad RE Michael, all the heat pumps we bring in at the RE Michael company have high and low pressure switches on them. The high opens at 620, closes at 410. The low pressure opens at 15, closes at 40. You remember when we first went to 410A, they had a POE oil, and they said it was a polyester oil, and they called it hydroscopic. It was always looking for water, so everybody had a loss of charge switch on it. And so this is, I think that still applies today, even though some manufacturers have stopped doing that. So we need to make sure we don't lose the refrigerant, suck any moisture into the system, and degrade the compressor and on these things. Because we don't, we're going to end up with more changing the compressor because we had a leak after we fixed the leak, and that's never good. Or even having to change the oil on a welded compressor, which is very, very hard to do, and I don't think any of you guys are going to do it. But anyway, so listen. We've talked about 20 minutes. We talked about 20 minutes about the basic heat pumps, We've talked about TXVs, how they work, and bypasses. We've talked about using nitrogen. Use nitrogen, man. Don't think that this is just something that I'm recommending. It'll stop you from having extra service calls that you don't need, and your equipment will work better, and your customer will be happy, and you'll be happy. You'll be able to catch more calls, right? Make sure you understand that subcooling and superheat, which you're going to have a class on that later, that you're using that to charge with, and make sure that you're doing the proper things and not tripping over the pebbles we're talking about. I think you're going to be very happy with Fujitsu products if you buy it from us and use it, and we're here to support you in any way we can. Our success, like I said, is tied directly to your success, and we want you successful. So I'm going to be back in about 5 minutes, so take you a 5 or 10 minute break, and we'll start talking about wiring.